Hi everyone, I'm David Myall and this is the second in a series of short talks about the piping life cycle. And in this session we're going to talk about something I'm calling work preparation. That may be a term that's not familiar to you. There are many other terms that are used, but essentially we're looking at what happens to piping data once it's finished in 3D design, it's been handed on to piping fabrication. So we're going to start with the typical issued for construction piping isometric drawings and a line list. And the line list gives us information on things like temperature, pressure, fluid, and a number of other important things that we need to do. Because the work preparation step is really about planning for the actual physical fabrication of piping. Now I've written data here underneath the ISO because the important concept that we started with in the first talk was about don't just think about this as being a piece of paper or a document, think about it as being some data that we originated in the 3D piping design system and we're going to use that data, we're going to add value to it and derive more information from it. Now the classical next step is to split up this ISO, this piping data, into a series of spools. Now, if you're wondering what a spool is, it's the piece of pipe that you can manufacture in your pipe shop. So there's no hard and fast rule, but it's something that maybe you can fit on the back of a truck. So typically a pipeline will be split down into a number of spools, maybe 5, maybe 10, depends on how big the pipeline is. And each spool is going to be fabricated in a piping workshop as a unit and then delivered as a unit to the next stage in the process. And if you think about it, if we take a set of spools, which are the things that we fabricate in the shop, there's likely to be a few other things, which we call the erection material, which is separate to that and also has to be delivered to site in order to completely fabricate this pipeline. So if we start with a line, we break it down into a series of spools that can be manufactured and available material. Now, we can start to derive a lot of information to help us plan this next stage in the process. So we have a constraint. We have a certain capacity in the shop. We can bend a certain amount, a certain size of pipe and so on. Obviously, there's a dependency on how much work is in the shop already. So that's one of our constraints. We have a load of legal requirements that we have to meet. Maybe project standards, company standards, national, international regulations that determine the quality that we have to apply to our piping fabrication process. Now, each spool is a unit that we're going to fabricate. You can think of the pipe shop as being kind of an assembly line, and we need to do a number of things. First of all, we need a drawing that tells the people in the fab shop what they have to do, and that drawing is a drawing of the spool specifically. In order to fabricate that piece of pipe, we need material to be available at the right time and in the right quantities. We need to figure out how many welds we're going to have to do to fabricate that particular spool. We need to check that the spool is within the size and weight limits that we have. We might want to calculate the work content to make that spool so we can use that information in planning. That might feed through into a cost estimate. Very important, we can determine quality requirements, what testing we have to do. And we can start with the information in the line list because that's going to tell us, for this particular combination of operating temperature and pressure, of fluid, of material, what the testing requirements might be. A high pressure line with a very toxic fluid needs more rigorous testing than a low pressure line containing firewater. So the quality and the requirements for testing, the testing protocols can all be derived from information that came into our process. Last but not least in this list, we have to generate a lot of documentation. Typically, depending on the local work process, there could be anything up to 10 or 12 pieces of paper that need to accompany each spool as it goes through the piping fabrication process. And you can start to understand the importance of, first of all, automation in saving work, because by applying some rules to the data that we receive, we can derive a lot of this information automatically. And the second thing, in terms of generating the certificates and documentation, we can see that the last thing we want to do is to manually extract data from all these pieces of paper and move them onto other pieces of paper. It's very much more efficient if we can actually use the data that came in to transfer it, to map it, to move it, and to repurpose it for the purposes of creating all these materials. So essentially the work preparation step is literally about preparing for work, for the next stage in the fabrication process. And there are many things that can be done to reduce the amount of work that is done manually and to minimize the amount of copying of information, transcribing information, which always leads to error. So we can drive down error and we can save on work by minimizing manual effort. So think of this as a digital chain. Data comes in here, we process it, we produce more data and documents and certificates. So that's it for this part of the process. In the next one of these coffee break talks, I'm going to be talking about the actual fabrication of the pipe in the fab shop using all this information. Thank you.